Hello again everybody, Steve from the Pinball Room, and today we're going to go through and actually connect up the rest of these mechs we've added to our play field. It's not 100% all the mechs we're going to have, but it's pretty much everything from the bottom play field. And I want to go through and do some play testing with these before we jump into the upper play field in case there's any other changes we want to make. Okay, so we got to go through and add power to each of these. High voltage power, we got to go through and connect all their grounds to our fast I/O boards we're going to be using, and then we've got to go through also and do a little bit more coding, actually a chunk more coding in our config files for MPF, Mission Pinball Framework, so we can make all that talk together, so we can hook it up and start playtesting and having a lot of fun. All right, so first things first, I want to talk a little bit more about the boards. We've got in here our first primary board. It's called the Fast 3208. The 3208 stands for 32 switch inputs and 8 high power coils that it can drive, all right? 8 coil drivers. Now, that's typically used pretty much just for your lower third, because between your main flipper mechs, your slingshot mechs, and then your trough mech and your auto launch mech, that pretty much gets you to almost 8 drivers, all right? That's like 6 coil drivers right there. And you can do a couple more on that board also if you want to. And then the 32 switches, because believe it or not, there's a heck of a lot of switches below this. You think, okay, we got a switch for the flippers, right? For each flipper button. We've got buttons or switch inputs for each of the slingshots. There's 2 there. That doesn't seem like a whole lot, right? But then you got to think again, you've got all the switches for your in lanes. You've got all your switches down here in your trough and for the auto launch. And the trough, if you have like a 6-ball trough, there's going to be, you know, a minimum of 6 switches there. Anyway, it adds up pretty quickly. So we probably won't use all 32 switch inputs, right? But we're going to use a chunk of them. And that's pretty much going to use up all of our coil drivers also. So the 3208 is generally recommended to be handling pretty much just your lower third and, you know, whatever else kind of within the region fits. But is not going to have enough drivers left, coil drivers left, for everything else we have. We've got a lot of coils in here. We've got our first pop bumper. We still have yet to add our second pop bumper. So that's 2 more. That would fill up our 3208. But then what else do we have? We've still got a coil for this 4-bank drop target mech. We've got 1, 2, 3, 4 more drop target mechs. We've got the mech we're using for our diverter, and then we've got the scoop, the buck coil right there. So 1, 2, 3, 4, 5, 6, 7. There's another 8 just right there. And so we could just get another 3208 board, but if you've been following along, and from my recommendation early on was to go through and get the Fast Starter Bundle. That comes with a 3208, comes with an 0804, which is a really small board for 8 switches and 4 drivers, and your nano board. The other thing you can go through and do, what I recommend, is that you go through and buy a la carte separately a 1616 board. 16 more switches and 16 more coils you can drive. Now, again, it totally depends on what mechs you're going to have in your pinball machine. As you go through and plan it out, maybe you're not going to have so many drop targets and things like that we're having, right? So maybe you don't need the 1616. Maybe the 0804 is going to be fine. For a lot of people, a 3208 and a 0804 can't handle a pretty sophisticated game, okay? But if not, he's got other options, which is great, okay? I love these board sets. They're working out great, so kudos to Fast. So here's the 1616. All right, we've got 16 coil driver pins up here we can connect into, and then we've got another 16, okay, for switch inputs that we can drive. So this has the same RJ45 connectors that the other ones do. So we're going to connect these in a series. If you remember, we have from our nano board, we have one comes in here, and then comes out of here. And I did have this just going straight back to the nano board. We just had a single board, so it's a really short, simple loop. Now we're going to go from this board to this board as the second one in line, and then from this board back to the nano board. That's going to be important to keep in mind when we get to the whole software coding side, which we'll do in a separate video. I don't want this to take like an hour long. All right, so for today, we're just going to focus on going through and getting all the wiring done, okay, getting all that put up in place. That's going to be a pause for today, and then we're going to go through and do a little bit more on the coding and into our config files, and we'll run through all of that in a separate video. Okay, so today's pretty short and sweet, a little bit of time lapse, and we'll speed right through into this. So, what do we need for tools? Not only do you get the board from Fast, but they also are nice, and they go through and they include, in the starter set, they'll go through and they'll include the different pins you need, okay, wire pins. okay? Different size wire pins that you're gonna crimp on, and those are gonna go inside these little handy dandy little plastic connectors, which will then, they'll marry up with the white things on here, boop, 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 and we'll plug them all in, right? Makes sense, right? Easy peasy. So if you haven't done that before, what do you need? Well, you need the tools that came with it, like I said, and then you're gonna need some sort of like a wire cutter and stripper, okay? There's different versions of this. This is the one I'm using today. And then you're gonna want one of these jobbies, and I'm gonna put a link up or a picture up with the name of what this was on Amazon. This is the iSwiss? I don't know, it's a Chinese knockoff probably, but it's got these fun little jaws here, these fun teeth, okay? I'm not sure just how well you can make that out, but each one of these and a ratchet, so it holds itself in place, which is super, super useful, okay? This is so much better than trying to do it yourself with like needle nose pliers or some other, janky way of doing it. Believe me, I've done that a lot in the past, and it works. You can get the job done. This will save you so much time, and not only that does it save you time and it's handy, but it also really ensures you get good crimps and good connects, which is going to be important. We don't want some flaky connections you go through and like they're intermittent and hardly ever work. So you want to make sure you have really good contacts. And these little jobs, I mean, this cost me, I want to say maybe like 20 bucks off Amazon, maybe 25. Okay, definitely worth it. It's awesome. It's this whole ratcheting thing. You don't understand how important that is until you start doing it. All right, you're going to go through and you're going to take one of these small little pins, okay, and this back side here just kind of has, it's kind of like in a U shape, okay. The wires, your wire is gonna sit inside that, okay, and then that's gonna go inside here, and you find the appropriate tooth. And for this one, it's number 3, and I click it just once, and it holds it in there. Okay, it's holding it for me. That allows me to even set this down if I need to. It allows me to pull my wire out. It allows me to strip off the end. This is 18 gauge stranded wire that I'm using, and I'm going to strip off not very much. Can you see relative how much that is? It's not a whole lot, okay? We're talking, let me measure it for you. We're talking a whopping 6.5 millimeters. We're talking 1/4 inch, okay? You only want to have about a 1/4 inch or so sticking out of this. Don't need very much. And then you're going to put the wire, I like to go through and twist the wire so I don't get little flyaways that don't go where they where they need to be. Put it in just to where the rubber is kind of right there at the edge, just a tiny bit of the rubber gets grabbed. And then you're going to just crank down. I'm not going to do it because I want to save this connector. You're going to just crank down all the way until it releases. And that's going to give you what's going to look like this. A super nice, this is a different connector, but it's going to give you a super nice crimp there on the end, okay? Now we're going to start going through and actually hooking these up and talking about we need to get the high voltage power and then the ground lines on each one of these coils, okay? We'll do all the coils first, then we'll come back through and do the switches. Doesn't really matter, that's just how we're tackling it, all right? So if you remember, I've just been kind of daisy chaining my high voltage power. I've got a line that comes in from the bottom of my cabinet, comes in from my power filter board, and it's coming straight in. I've got it going to my right slingshot, left here on the screen, right? Actually, no, that's my left slingshot. I've got it coming to this slingshot, then to this flipper, continuing to that flipper mech, and then to this slingshot, then to my upper flipper mech, and then it was dead ending there before, if you recall. Now I've gone through and I've gone ahead and I've gotten a bunch more wire and connectors all ready to go and daisy chains. So I went through and crimped them, and I already went through and kind of measured them out. I do them one at a time to make sure I get the right lengths. And remember, I'm still giving myself about 3 or 4 inches of play just in case we move things around. We are going to come back through and do a final wiring harness afterwards. For me, there's still too much that's not set in stone for my play field, and so I don't want to try to do like a perfect, super gorgeous harness right now. It's just not worth my time because I'm going to be constantly changing it. Okay, so from this upper flipper, which is where we ended before, I ran this first chunk of wire. Okay, I'm using blue for my whole high voltage. I recommend you try to use a consistent color, especially for the high voltage. You always know which one is power versus the ground. The most common is to use black for your grounds. I'm sticking with that right now, a color for high voltage, black for grounds. You do what works for you, but just make sure you're consistent. It's going to save you a lot of headaches later on. If you run out of wire and switch to a different color, Okay, we're still just early on. You can do that, but like write it down, somehow remember so you don't forget which one's which. All right, so this wire, I'm coming just kind of closest neighbor first. I'm coming over here to this side, to this pop-up. See, I gave myself plenty of slack just in case. All right, and your first question might be, great, Steve, how do I know which lug the high voltage power needs to go to? So if you remember back from our first earlier video about connecting up with power and getting flippers flipping that video, I went through and described that on a lot of the high power coils, especially like your dual wound flipper coils, there's going to be diodes, okay? The little plastic things, little black plastic things that have like a little gray bar on one side going in between the lugs. If your coils have those, you do need to be careful which side you put the high voltage in. High voltage goes on the side that has the little band on the diode, okay? That indicates the side that high voltage should be coming into. The other side is going to be your ground, okay? Now in some of these, like this pop bumper, there is no diode, and it's a lower power coil. It's a 26-1200. If you remember that from our earlier videos also, we talk about what those numbers represent, the gauge of wire, the number of times that it's wrapped around to create the electromagnetic field. But long story short, if there's no diode between these lugs, the coil's not really going to care which side the power is coming in and which side is going to be the ground. Okay, so you're safe to kind of put it on either one. And that's going to be how we are for our pop bumpers, for our drop targets, for the little coil we're using for the diverter, even for our scoop, the VUC, that up kicker coil. They're all low power enough that they don't really care which side the power comes in onto, all right? They're all single wound and it's simple. Okay, so with that in mind, we can go through and just connect from here to here. And then I grabbed another strand of wire to come down to these drop targets. Okay. And from there to the next one. And then the next one. Okay, we've got them all connected. Okay, one little trick I've learned along the way is to have this precision flathead screwdriver with me also. These coil lugs, sometimes they will not be totally smooth or super thin, and your little connector here might be a little tight. And so I will go through and take my flathead screwdriver and shove it inside and just kind of bend those prongs just a little bit to open them up so they slide on easier, right? You don't want them so loose they just slide on and off. You're not going to get a good connection. But some of them are so tight you will not be able to get them on. You'll start bending your lugs. You'll break off the lugs. So just find the happy medium. Don't be afraid to do that if you're using these quick disconnects like I am for right now. Again, final version will come through with a final wiring harness and we'll solder all these connections because that's how we're going to get the proper connections we really want for like a final game. Okay, but for now the quick connects are going to work good for us. So you might need to use that. There's a little tip for you. Once we've gone through and we've got the power to all of these, now you'll notice I skipped right now the power to this 4-bank drop target. Why? Because it's already got wires soldered on with a different quick disconnect. I'm going to keep that. I want to chop that off. I could, clean the solder and just go straight off and get my own wiring done. But this already has a nice connector, which makes it really easy to just kind of disconnect and pull out if you have to work on it. So I'm going to keep that. I like that. So we'll come back through and wire that up in a later video. But now we've got all the high voltage in. It's all daisy chained around. We're good there. Now we need to go back through and start putting our grounds on each of these coils, which will then go back straight to our 1616 I/O board. And those grounds are what are going to control, closing the connection and getting these coils to fire. Okay, so same thing. We're going to get some black wire. That's what I prefer to use, and start going to town. Okay, so from there, we need to go through and do all of our black ground wires, which are going to be going from the coil straight to the 1616 I/O board. And those grounds on that board are what are going to open and close the connections here to then fire these coils rapidly. We need to go through and mount our 1616 board. I still prefer to do a vertical mount to save as much space as possible. I'm just using these simple little 90-degree elbows, little pieces of metal, little brackets I got from Home Depot for securing up cabinets and stuff, with a couple of plastic bushings that I'm putting on either side, just kind of protect the board. And then need to find a place. I've got a board down the side here. I should have room and nothing much going on over here. So I'm going to put this one over here. Okay, and like everything else, final position until we get all the inserts in and all the lighting, which is still a ways off. We don't know exactly where it's going to be the best place to put it. I feel like that's going to be a pretty good spot There's not going to need to be a whole lot of like, you know, lights and inserts around over there by that orbit, but it might be a switch. We could end up moving it later on. Okay, so same thing. We're going to grab some black wire. Okay, and I'm going to say on this one we're starting from the very beginning, 0, 0. Okay, so that very first switch, or switch 0, ground 0 on this board, is going to go from here, and I'm going to go the same route. I'm going to come to this pop bumper. I'm going to give myself a little bit of extra. I'm going to cut it. I'm going to crimp it. Okay, and we're not connecting these. Each one of these needs to be its own wire. There's no, you know, daisy chaining of these. All right, or else the signals all get mixed and everything will fire when only one's supposed to fire. Okay. Now this uses a different type of pins. Instead of those quick connects, it's going to use these silver ones that came with our fast boards. Okay, and these little jobbies. Okay, the ones I showed you earlier with that little U on the one side there. And we're going to wrap that around the end, and then that whole thing is going to slide inside here and connect. Okay, that's on the one end. Okay, and so this first spot is going to go to the first spot there, so I'm going to do that and slide it in place. And then on the other end, I do need to go through and use my quick connect on the other end. Okay, and I've cheated. I've gone ahead and done all of these. Okay, so I've got a whole like Medusa thing here of all these wires. Okay, so here's all the different wires, and they're all going to come into this board, and once they're all done, you can slide this connector in place. Okay, 0, 0 is for this pop bumper here, and then this is for my first drop target here, the next one in line. Now when you're going through and doing this plastic connector here has a spot for every single possible hole. On the board itself, can you tell that these pins, we go 1, 2, 3, 4, 5 pins, then there's a gap, and then another 5 pins, okay? And on this board, there's 4, then a gap, okay? And then more. So as you're going through and putting those in, and you actually slide them into here, make sure you double check and don't slide one in. There's a little triangle or a diamond here on the side also by the numbers on the board. You need to leave that one blank, all right? That's important, okay? So make sure you're watching out for that so you don't put a pin in one of the wrong spots. You can pull it back out. Again, that's with that flathead precision screwdriver. If you put one in the wrong spot, as it slides in, there's a little tab that kind of pops up and snaps into place. You'll need to depress that and then be able to pull that pin back out. Do it very carefully so you don't end up like bending that wire all backwards and wrong and ruining your connection. Okay. Once we've got all these in place here, they're all connected. These last 3 pins on the board, you'll see GND for ground. We need one of those. I grabbed the very last one, doesn't really matter which one. Needs to have a black wire that runs all the way back down through into the power filter board, okay, for its ground. Now, as you go through and you start getting so many of these lines out of high voltage, so many lines of grounds and all that, there's only so many high voltage outs and ground connections out from the power filter board. Some people go through and get a terminal bus where you can go through and basically kind of splice that out. So like a single high voltage can now splice out into multiple high voltage lines. And that makes sense because if you have enough high voltage power cables, you don't really want to daisy chain like 6 or 7 flipper mechs all together. That's not really all the proper points of failure you should have. I'm not an electrician, but from the guy who is an electrician, I've been asking questions of, you might want to get to a point where you're going to go through and split off that high voltage. And then in addition to just the fuses that are in the power filter board, we might need to add another couple of fuse blocks here inside. If you've looked underneath pinball playfields in the past, you've probably seen that, right? Some of the older games will have a fuse right in line by like a flipper mech, etc. They only want to have a few on the same line with its own fuse. So if something blows, you kind of just shut down that portion. The rest are not going to be damaged, etc. So that's probably the best I can explain that one right now. For today, we don't really need to worry about it. We're okay to daisy chain. We don't have a whole lot going on. This is not the final production setup. But instead of having one thing of high voltage going through and powering all of these, when we actually get set and done and do our final wiring harness, we're going to start to kind of chunk things out, all right? And we'll have a line for, again, like the primary 4 or 5 mechs for our lower third, and then we'll have some other things dedicated. If you have like any particular like servos or any like stepper motors or other type of like DC motors or other things for special mechs, you might want to start thinking about kind of isolating them onto their own lines or down to just a couple of mechs on a single line, etc. Again, We'll have another video when we get further along doing our final wiring harness where we'll talk more specifically to understand how exactly to group what together and where to put fuses, etc. But for now, we're going to be okay for our play testing to do all this. Okay, so that gets us through to where we have our power connected and all of our grounds set up. Now right now, they're not going to do anything because there's no switch inputs connected to them, okay? All right, so the next step is to go through and do the same process again with different colored wire, and we can use smaller wire. 22 gauge is what I use for switches instead of 18 because it's carrying very, very, very low current and voltage. We're going to go through and connect the switch from our pop bumper, okay? And those grounds for switches, you remember the grounds for switches we can daisy chain, okay? The other end is going to come into this smaller piece of plastic with smaller connectors, and it's going to connect over here on a different place on our 1616 board, okay? So now we've got to go through and do all those wires. All right, that actually worked out pretty good. So that's just quick to demonstrate that we got everything hooked up, power going, config file hooked up. It's working. Everything's great. So that was just a pop bumper. It's an auto fire coil we talked about in our last video. And I'm actually pretty pleased with how it's interacting with the ball. I don't know. We'll see. We might yank it out. But anyway, there you go. So hopefully that gives you a quick rundown again, refresher on the wires, the switches, the grounds, the coils, throwing in a second board. So hopefully that was helpful to you. All right, so tomorrow we'll sit down at the computer, I'll record my screen. I'm gonna walk you through how to build out your config file with each of the different little entries you need to make. So the coils and the switches are all working together nice and easy. It's really not that difficult once you kind of get your head around it. I'll walk you through it. The guys building the software platform, Mission Pinball Framework, they're doing a great job. It'll be a breeze, guys, trust me. Okay, if you haven't started building your own pinball machine, why not? Get on it. Okay, catch you next time, bye-bye.